Okay, so just outside Runcorn, in northwest England, is a village of some 1,000 people called Weston. There was a chemical dump here that for 50 years was used by Imperial Chemical Industries, ICI, to dispose of toxic waste. However, in 2000, the gas level of a highly dangerous gas known as, here we go, hexachlorobutadiene, or as I prefer to call it, HCBD for short, was so high, ICI evacuated some 21 families because their houses were considered too unsafe. The gas had seeped into the actual homes and a local scout hut. The gas, a byproduct in the production of chlorine, can cause fatty liver degeneration, kidney issues, central nervous system depression, a reduction of oxygen in your blood. So it's not very pleasant. The BBC documentary series at the time, Panorama, used the incident to highlight the inherent dangers of building new homes on former industrial chemical polluted areas, brownfield land. ICI sold its chemical interests in the area later that year to a relatively new British company, a chemical company. I hadn't heard of them, INEOS, which is the fourth largest chemical company in the world, set up by Sir Jim Ratcliffe, who currently is just bought for 25% of Manchester United Football Club. The globe's appetite for chemical products is huge. For example, along with hundreds of other products, 250 million tonnes of sulfuric acid and 65 million tonnes of chlorine are manufactured worldwide. ICI, Imperial Chemical Industry, was a notorious polluter. Channel 4's documentary Dispatches reported high dioxin levels in farming land near ICI's chemical plants in around Weston, around that area. Then they were joined by Friends of the Earth a couple of years later, who complained that ICI were dumping far too much toxic waste in the Cheshire countryside. A year later, we also found out that ICI was using the Western Canal, which is a short canal in Runcorn, these are all next door to each other, designed to link it to the Bridgewater Canal, which you will have heard of probably from former talks. And it was really basically used now as a drain for waste, with pollution 20 to 60 times higher than the European Union's standard. And I will also add to this, just off the cuff, it's not a coincidence that they're getting rid of all the European regulations to manage British chemical industries, which will encourage investment, but at a price, of course. In 1999, Greenpeace declared that the Cheshire countryside was one of the world's toxic hotspots because a lot of dumping in the old salt mines and so forth. The Member of Parliament for the district, that's a guy who's still Member of Parliament for the district, Derek Twigg, told the House of Commons, quote, "The heritage of the alkali and chemical industries over the past 150 years has been chemical waste tips of the most unimaginable kind. Our Victorian forefathers thought nothing of filling in ditches and watercourses with toxic waste from factories." End of quote. There's more, might surprise you, there's more derelict land in northwest England than any other area in the country. And that's probably due to its legacy with the chemical industry. It's also has the lowest, I didn't know this, has the lowest tree cover in Europe. A report, finally, by the University of Lancaster in 2003 by, I expect, a geography department or one of the science departments, wrote, "It is likely that the past history of environmental pollution in Halton, Runcorn, Widnes, and those areas, has had a major bearing on the health of long-term residents in the borough. More precisely, they concluded, quote, "It is probable that significant risks to public health and to the environment do exist in those areas previously used for industrial purposes." And this is Halton. And by the end of the 19th century, Widnes, Runcorn and St Helens, they're the areas I'm particularly interested in, produced 3/4 of all the chemicals manufactured in Britain. But, you know, living there, you see it. And yet no one really talks about it. Even the boroughs don't talk about it because, apart from the MP, they want people to think they're living in a nice place. And your property values will go down, and it's economic reasons. No. Anyway, recently, one former resident of Widnes, the best-selling novelist Stuart Turton, I don't know if you've heard of him, reflected in The Guardian, this was only about 2 years ago, on his memories growing up in Widnes, quote, "On a map, it looks as if it's sidling up to Liverpool, where my university is, to scrounge a cigarette. Manchester has taken a step back, probably to get away from the smell." Such is the reputation of Widnes and its smells. A recent Arts Council financed a project to document these smells, and the venture was organised by the local Catalyst Museum, which is a chemical museum. Have you been there? No. It's worth going to, actually. It's got a collection that no one looks at. So I shall be using that if I can. Anyway, this is the smell map by the Kate McLean. And it just says 2 centuries of stink. Weston, Runcorn, Widnes and St Helens have some of the highest levels of poverty and health problems in the country. In 2018, it's only 5 years ago, it was recorded that parts of this region held the dubious title of having the record for cancer rates in the UK, with lung cancer being particularly high. Could it be then, this is my natural thought, more people smoke here? Well, no, according to Cancer Research UK, who states smoking levels are the average, similar to other. So what's triggering this poor health and damage? Could it be something related to the legacy of the chemical industry? Well, that's what I'm hoping to find out a bit more about. And that's what I'll discuss a bit more with you and what you think. In some ways, the history begins, we've got to start somewhere, with the arrival of James Muspratt, a one-time Irish soldier and Navy deserter from Dublin, who inherited money and set up a chemical works in Liverpool. Another reason I got interested. It was in the Vauxhall Road. The Vauxhall Road is this one here, and that's not far from the dock's edge. You'll be familiar with all that. You probably walked along there. So it's easy to import and export. The plant initially produced Prussian potash for making the Prussian blue dye, and later oil of vitriol. That's the original term used for sulfuric acid. And that was used for textile bleaching, for soap making, especially soap making, glass production, and of course later paper making. So bleach, I mean, so important. And we don't talk about its history as much as you'd expect, really. Sorry, I'm going off tangent, but as a historian of industrial revolution, it's always cotton or iron. I'm guilty of it. Prior to its use for textile bleaching, the purpose of oil of vitriol, sulfuric acid, was primarily for cleaning metals. So it gets quite big in the Midlands. And it's made by druggists as well. Pharmacists, what we call now, but people who make medicine. And interesting, its production on a significant scale originally began in Twickenham in West London during the 1730s via a plant run by a quack called Joshua Ward. More famous today for producing pills that he claimed could cure everything, but actually poisoned you. He formed a partnership with the aptly named John White, in which they produced oil of vitriol and put it in large, this is quite innovative, large 40 to 50 gallon glass containers. I'm more interested in the glass makers. I mean, to make something that size would suggest he had access to very skilled glass makers. I will get a little bit technical. The acid was made by burning sulfur and nitra and absorbing the gas in water. Ward had spent, this is the link here, you said you were interested in transnational. He spent 15 years in France fleeing the law, where he probably encountered and was informed by the work of people like Nicholas Lemery, who's known for his research on acids. Forgive my pronunciation, by the way, and also Etienne Francois Geoffroy. Have I said that okay? Okay, well, I won't say it again. Who spoke about, of course, the affinity of substances being attracted to one another. This is interesting. In 1740, Ward and White had to relocate to Richmond after complaints from local residents in Twickenham for causing a nuisance. And you know all about nuisances. It was the term used for pollution. You know, the idea of risk society, they knew what they were doing then. Shortly later, the glass vessels, this is interesting as well, changed to even larger lead containers. to improve the safety of the transportation. Not surprisingly, where does that start happening? Well, Birmingham. This change is spearheaded, though, by the Sheffield-born Sunna Cutler and Edinburgh and Leiden University medicine graduate, a guy called Joe Roebuck, and that's why I want to go to Birmingham to look at his archive. And then you've got the brass worker, Samuel Garbett, first in Birmingham and then so they set up two factories, one in Birmingham and one in Preston Pans near Edinburgh. And my guess is the one in Birmingham is for the metal industry, the one in Edinburgh will be for the linen, which we'll come to. So they're perfect locations, really. The bleaching of textiles was then still dependent upon the sun and laying it in bleach fields covered in sour milk in Europe. I mean, that was everywhere, but I live in the northwest. We don't see much sun. It couldn't have been that great. In Europe, the major developments in this area, hitherto, people forget about the extent of the Irish linen industry, so they were very up on this, as of course were the Dutch, with all their dairy products and the milk, sour milk, Haarlem, around that area. Many of the Dutch came over, in fact, to Scotland. We were talking about transnational peoples and the importance of that input. However, it was known that a dilute oil of vitriol, sulfuric acid, rather than sour milk, could be substituted and speed up the process of bleaching textiles. And in 1756, the Scottish savant Francis Home had found that a weak oil of vitriol solution was more efficient than using sour milk. However, and this is the key point, it could also ruin the cloth. So getting that, the right dilution is really hard, and that's what they were fighting with. The traditional linen process, back to the bleaching, went through distinct stages. So linen, when it's first manufactured, is grey and has to be washed several times with soft water and alkali detergent, still thoroughly clean. Several thousand square feet of this fabric is stretched across the valleys, the hills, and I mean, I haven't got pictures of it, but obviously it's valuable. So they have guards around these and holes underneath the textile. So if you are successful and get there, you'll fall in a pit. So there's lots you have to. So it's expensive to police as well, these places. It takes a lot of equipment and so forth to keep washing it and stretching it and so forth. So what if an alternative could be found? Although the Swedish man of science Carl Wilhelm Scheele had located chlorine around 1772, it's not really till the late 1780s that a new bleaching agent had been created, namely chlorine gas. And this was associated with the work of the French savant Claude Louis Berthollet. He synthesized and reduced muriatic acid, which we now call hydrochloric acid, with manganese dioxide to produce this gas. This was then added to water to produce a liquid bleach. Now, the British drew upon that, but instead of using muriatic acid, they used oil of vitriol. And then they would dissolve it in water mixed with potash and lime slurry. It wasn't hugely successful. The Scottish industrialist James Watt, you all think about steam engines, he's as active in this sort of business as well, tried to use oil of vitriol and salt to dissolve the gas. And what's his aim? Well, it was to help his father-in-law, father of his daughter, his wife, who owned a bleaching works in Glasgow, James McGrigor. I don't know much about him. I tried finding about that works. Simultaneously, Patrick Copland, Professor of Natural Philosophy at Marischal College in Aberdeen, had teamed up with a local manufacturer to try and do the same thing before James Watt. These are key areas as well. Why Scotland? It's the linen industry, it's the bleaching, it's so important. At the same time, again, I'm bringing the transnational dimension, two Frenchmen, forgive my pronunciations, you're laughing every time I look over, I say something. Antoine Bourbon de Bonnet. Is that quite good? I did try, I've tried. And Matthew Vele moved to Lancashire and started producing a bleaching solution based on Berthollet's work. Both had experience, and this is interesting, I like this, running a chemical factory making oil of vitriol at Jevel on the outskirts of Paris. Their first factory in Paris was shut down for causing a nuisance in 1777. So it's everywhere, these nuisances. And I don't know, I hope you can tell me, the outskirts of Paris appears to me incredibly interesting for this story, and I'd like to know more about what's going on there. And I know that a lot of it's written in French, so I haven't... we'll come back to that. Anyway, of course, Vallée is known for his work as a balloonist using hydrogen gas. In England, they were sponsored, this is interesting, they're sponsored to come over by a wealthy textile bleaching and cotton spinner, a guy called Thomas Ridgemont, who runs his industry on the outskirts of Manchester. So Bonnet and Vallée appear to have diluted the chlorine gas in a solution of caustic soda, sodium hydroxide, since they argued it absorbed more of the gas. Berthollet hated them, but thought they got that bit right. Their aim, like Watt and Copland, was to speed up the bleaching process. They applied, long story short, it's quite an interesting story. They applied for patents, rejected. The manufacturers in Lancashire really object to anything to do with patents. Watt, of course, is involved in this, but is worried about his own patent for the steam engine, so he doesn't get too involved. The eventual process, however, came a few years later in France, and it's typically, rightly or wrongly, it's a grey story, associated with Nicolas Leblanc. The subsequent pioneers of textile bleaching in Lancashire and Scotland were former French employees of Bonnet and Vallée. In particular, Vallée seems to be really more important here, along with this guy called Hugh Foy. Never heard of him, F-O-Y. Must have come over as well. Don't forget the Irish Linen Board are also trying to sponsor these projects. Richard Kerwin and so forth. Following Berthollet again, trying to produce the right type of bleach for textiles. And it's Foy who actually taught Charles Tennant, who you may have heard of, a Scottish handloom weaver by trade, to make a liquid bleach from chlorine. And he develops this alongside 4 partners who you may have heard of: James Knott, Alexander Dunlop, I presume of Dunlop fame, rubber, Dr. William Cooper, and Charles Mackintosh of Mackintosh coat, waterproof coats fame. And they create a dry product. Tennant forged a combination with this above group, who founded a chemical works at St. Rolax in Glasgow. It's a bleach powder. You're bleaching the liquid into lime shell, damp, which makes it much more transportable. And so the development in textile bleaching was as important, I'd argue, as new spinning technology. It's just that we all know the story of cotton spinning technology, but we don't know this so well. Not saying we don't, it's not so prominent. So it's now cheaper and safer to transport and easy to apply. We're not talking about soda ash here, we're talking about bleaching powder still. Tennant did not start producing soda ash, sodium carbonate, using the Leblanc process till probably the mid-1820s. So chlorine powders is a really important thing, and he becomes dominant in that field, right, in Scotland and Lancashire. Soda ash is different. It's used for cleaning and enhancing the colour of textiles, and is a key ingredient in soap, glass, and later paper making. However, in terms of textiles, the bleaching powder underline was the most important, and typically 1 part of the powder is mixed with 10 parts water. Okay. So we've also got to be clear what we mean as well. It's wonderful for cotton, pure cotton cloth, not so wonderful for linen. So linen still remains bleached in the fields a lot more because it needs it. I love this picture. Talk about vanity or the age, but in 1842, Tennant's factory chimney, known as Tennant's Stall, was 435 feet, or if you prefer, 133 metres high. And it was deliberately measured as the same as the Great Pyramid of Egypt. Mm-hmm. In general, the mass production of synthetic soda ash did not really commence till the 1820s in Britain. I don't talk about it, but we can in questions. No, just they kept building these chimneys higher and higher and higher because it would pump out the pollution further and further and further, so it wouldn't land on their doorstep. Well, not a solution, but it helps the reactions. But we bring that up in the questions if you want. Okay, hitherto the process was reliant upon imported, this is for white soda, imported Barilla, ash from the plant grown in Spain and the Canary Islands, which is subject to an import duty at this time in Britain. And it contains about 14 to 20% of soda. Also, there's ash kelp, which is basically seaweed, which is picked up around Scottish Highlands and the islands of Scotland and Ireland. And it's got less soda in it, but it's still a good source of natural soda. So the kelp industry, especially in Scotland and the Highlands, becomes really quite important to their economy. And it'd been the scarcity of natural soda, that stimulated the French Academy of Sciences to offer a prize in 1775 to make alkali from non-vegetable, synthetic alkali from non-vegetable sources. And that leads to the story of the LeBlanc and so forth. So what does he come on? He starts using things like charcoal and salt and limestone in 1790. You'll know far more about his history than I will. France was more reliant then on Britain upon imported Spanish Barilla. That's a key point. The former also had an advantage, this is Britain, because it could import other natural sources like potash from the American colonies, mainland. So Britain was less worried at this moment about synthetic alkali. After the Napoleonic Wars, they spread to the Iberian Peninsula, of course, in 1808. But from our point of view, it leads to a reduction in supplies coming to France from that area of natural soda. So you can see why there's a much more of an impetus here to create synthetic soda. And of course, one of the main areas being targeted was Marseille. I have been to Marseille. It's an amazing place, actually. So different. I mean, you could be anywhere there. Anyway, that's neither here nor there. I must stop doing that. By this stage, the textile and soap manufacturers of northwest England, manufacturers in London and West Scotland, had also greatly outstripped the supply of natural soda. So there's an increasing attempt to reproduce it here as well. Traditionally, the London soap makers used Barilla, like the French, and the Liverpool manufacturers were using the kelp, unlike the French. When the duty on Barilla was lowered in 1822, it enabled the London makers to lower the price of their soap at the expense of the Liverpool soap manufacturers. And it's that opportunity, more than the massive reduction in salt duty in 1823 and its abolition in 1825, that attracts the Irish industrialists, Muspratt, to Liverpool. He thinks if he can create synthetic alkali, which we know he can do now using the LeBlanc process, he could start supplying really cheap supplies to the local soap makers, which is why I want to go to their archive. That is held by Leverhulme, actually, Lever Brothers, in the Wirral. Manufacturers I haven't heard of before, but big at the time. So he starts producing soda ash using the LeBlanc process in 1824. Now, he's not the first to do this, but he's the first in Britain to do it on a mass scale. By the 1850s, Britain actually dominates the production of synthetic soda, that along with coal, of course, is one of the most polluting products of that century. Muspratt kind of gets evicted from Liverpool. He moves to St Helens. Then for some reason, he leaves St Helens and goes to Newton the Willows to set up his production process. They're all nearby. That's all important. But this is away from rich people who can sue you. At the time, to make white soda via the LeBlanc process, you began by constructing these big lead chambers to contain the oil of vitriol. And you made the vitriol acid by heating sulfur with potassium nitrate in a sulfur burner that produced sulfur dioxide. Sorry to go on about this dioxide gas that fed into the lead chamber. All this stuff, the reason I'm mentioning it, has to go somewhere. There's a lot of waste. It's very wasteful. The resulting salt cakes at the end of this process are then placed in flames till all the remaining chloride evaporated. And the subsequent product would next be reacted with coal and limestone. This is the hard part, though. Historians, this is a really skillful job to work these things here to make the black ashes draw out. I think these are called soda candles, these little sparks that you can see here. And I think the skill is, through those candles, you can judge the rate and the state of the production. No one, as far as I know, this is all tacit knowledge, but I'm trying to work on what I suppose you should have to recreate it, but I think it'd be a bit dangerous. Anyway, this turning and thing, and as with all innovation, you learn from the social, then you can mechanise it. So later on in the century, they build these big revolving machines which empty the black ash into here. Okay, but this causes an immense amount of waste which is dumped all around the works. Don't you look? So this is Newton the Willow. This is Muskrat's plant, and it's still there, and it's called Mucky Mountains. Any guess why it's called that? Mucky Mountains. See these things here, and that of course is all waste from the chemical plant. Notice nature has recovered it, but I still wouldn't want to grow my tomatoes in there, or vegetables particularly. So I find these sort of things, or archaeological evidence, really quite interesting. From the from the mid-19th century, sulphur derived from iron pyrites rather than the raw natural soda from Sicily. This is where they would get their raw sulphur from, was used. The iron was imported from Ireland, North Wales, and later Spain and Portugal. And that contains about 53% sulphur. But there's a problem. In trying to liberate that iron, you are also you're causing arsenic vapour, because it contains a lot of arsenic. And that arsenic gets into the waste and is also dumped around. So I haven't mentioned it in the talk, but it's very interesting how we can talk about it in the questions, I won't go off, about solutions to these issues at the time. Because even though I'm not really into the risk society, it has implications, I think, for that whole question of when it arose. Is it a modern thing or older than you think? The nitra was imported from Peru. Initially, all the undecomposed nitra was dumped with the salt waste. Nitra's quite explosive. It's quite dangerous as well. You make dynamite out of it, don't you? But it's crude black ash that Muskrat utilises to sell to soap makers. Can you imagine, though, in the 1820s, you're a soap maker and you look at this black ash and you think, really? It's black as well. So it takes a lot. He has to convince them, work with them, that this is going to work, and it eventually does. So they accept it, and that's when Merseyside overtakes the production of soap from the rest of the country, from London and elsewhere. So the rise of oil and vitriol making, sulfuric acid, soap making, glass making, and so on, can't be pulled apart. You know, they're all connected. Textiles, you have to put on the list later paper, I said that. Alum, which is used as a mordant in textiles to hold the dye. You know, all these things need sulfuric acid. By 1830, Muskrat and other manufacturers started making much more of the stronger white ash than the blank soda. And that has also, it's much easier to transport and not decompose. Also allows soap makers to use cheaper other ingredients. So it's not just you're using this new chemical substance, but it's also enabling you to use other things like palm and vegetable oil rather than the more costly use of animal fats. And this, again, puts Merseyside at the front, most of that coming into Liverpool and close by. So by the 1830s, Merseyside is outstripping London as soap makers. That's, I don't know, people laugh when I say it, both soft and hard soap. So it's actually significantly the most important area, 50% more than London. Its location then, proximity to raw materials, as I'll come back to in a minute, make it ideal. And the Port of London, of course, is the Atlantic port by now. So the main customers for this stuff were the soap producers in Liverpool, Warrington. Poor old Warrington never gets a real say, but there's some big soap makers there that I want to look at. Widnes and Runcorn, along with glass makers in St Helens, which is also needed, of course, bleaching powder especially, and also soda with Lancashire textiles. Right, let's just talk a little bit more about the glass. Despite this new installation being built over what was Pilkington's glass, so this thing, by the way, I googled it. It basically recycles glass and puts it into that insulating stuff you put in lofts, and so that's what they make there, I think. But it's significantly bang over Pilkington's. It's almost retained the same shape. I mean, you can still, this is the point, you can still see remnants of what was Pilkington's glass, which is a massive glass maker. They have two Bergies, they call them Bergies. That's not my pronunciation, that's what they call them. But either side of the town of St Helens, and that's all waste from the glass. Again, piled up high. So St Helens became the major centre for especially plate glass making in England. The nurturing of plate glass production was an attempt, and this again is interesting for this group, to stem the dominance of the French glass industry, particularly at Torlevel and Saint-Gobain. Those seem to be the two key areas. Much of the necessary knowledge in St Helens and the early glass makers is coming particularly from Saint-Gobain, I think, particularly there. Other types of glass, such as window and flint, were also manufactured at St Helens. But the key as well to the location is everything. Salt, I think, is the key to all this, to the chemical industry in northwest England. The main salt-producing areas in Cheshire are in Cheshire, which is just next door. Middlewich, Nantwich, North. You've been to any of those places? Yeah, you know them then. And these areas are really interesting because, I'll come to it in a minute, they have suffered now from severe subsidence issues. The salt brine, you're pumping out all this salt brine, the land collapses. So, for example, there are no buildings more than 2 levels in Northwich vicinity. The collapses led to the Brine Pumping Act of 1891 to compensate people that suffered. So you'd see the collapse there. That was quite a common sight near these industries. That's the last. You can see the land crumbling around here as well. The map is deliberate because it shows you've got Nantwich, Crewe. That's why I live Chester. Then you've got Widnes, Warrington. They're all close to them. Notice how close they are to each other. Salt, coal, everything you need is all nearby. So yeah, it took me 10 hours to get from there to here yesterday by train. Terrible. The worst part of Britain, of course, because nothing works. Okay, but this I've been to, the Linesworth. It's a museum now, but it's worth going to. You can't really, you can actually. You see the lake in the background? That's from land that's collapsed. And they've now made it into a nature reserve. So, fantastic museum though. You go in and you can actually watch the production, and they're singing folk music, or salt songs that they used to sing. So they're recreating, trying to get a real sense of what it was like. And all the women, it was all the women who put them in the bales or in the sacks. So they show you the division of labour, and I quite like seeing things like that. Also, the other key thing to notice about this is that good transport connections. They're absolutely vital, aren't they? Of course they are. Shipping coal in for energy, exporting salt away. In fact, Liverpool docks, the first item they used to export way back in the early 18th century was salt, before slaves became much more profitable. Okay, in particular, the Sankey Canal, later renamed the St Helens Canal, was built near the small river, the Sankey Brook, that runs from St Helens into the Mersey that goes out to the port of Liverpool. At the same time, the River Weaver, which will mean nothing to you, was developed to carry salt from Cheshire to the Mersey, back to Liverpool again. A couple of years later, and the Bridgewater Canal was completed, which you all know about, because it's often seen as the first canal, linking the Duke of Bridgewater's coal mines in Worsley, a village in Salford, to Manchester. The Sankey Canal was extended in 1832 to connect with Widnes, while the Runcorn Gap Railway gained a Parliamentary Act to be built in 1830, and that opened up in 1833, became the first rail-to-ship facility in the world. By the 1850s, Widnes had become a very well-connected area, and I'm not talking about people, I'm talking about transport lines. Offered significant savings in transport costs for the raw materials of lime. Don't forget, lime is really important, and you can get lime very easily from Derbyshire. You can start moving the finished article as well much more easily. The most famous being cotton, of course, raw cotton coming in from Liverpool, going to Manchester, the end product then going back to Liverpool, being exported. But I'm talking about the legacy of the chemical industry here. Now, we're doing all right for time. I've got about 10 minutes, I think. Is that right? Yeah. Right, why am I worried about all this still? Well, in 2004, for example, St Michael's golf course in Widnes, I've done a lot of Googling here, was shut down after it was found full of deadly arsenic, which of course poses a serious risk to health. The course was built in the 1970s, but the key thing is it was built over a former chemical dump. A few years later, it doesn't stop there, there's other examples as well, but a few years later, in 2015, a 37-acre toxic waste dump was discovered under Runcorn. More precisely, it was beneath this transport depot, Crosville. A layer of up to 4 metres thick of sulphur waste, known locally as Gallagher, covered 45,000 cubic metres of land. It's about that high. So they had to clean up the land there. And there's waste primarily from the blank chemical process. Water has been found flowing into the Mersey still, possibly the Bridgewater Canal, still carries lots of lead and arsenic. So it's in our water system, which is not the best with sewage at the moment in the world. In fact, every time it's heavy rainfall, you probably hear they illicitly dump tons and tons of sewage. In my river, the River Dee, people are falling down ill. It's shocking. It's really shocking. That's from privatising the companies. They don't invest in the infrastructure and just make share prices and so forth. But anyway, okay. Another example, when they built this big, you've been across this, but this big, very impressive bridge. But this is, by the way, is Widnes and Runcorn today. It links, in fact, Runcorn's here, Widnes is over there. Before they would build it, they made a really detailed study that I've looked at to look where they can't go. So it tells you, we found this here, that. And I think they're a bit too optimistic, actually, because I believe, and I haven't shown this, I'd like to find out that workers were falling ill. And I suppose you have to contact the local hospital to find out. I mean, the big company's not going to tell you. So, mustard gas, uranium being found also, because they used to make mustard gas on here, I think it was, in the Second World War, which I didn't use. And, well, I know that the army was sent in eventually to get rid of it. So I'll just conclude now with a few comments looking at my probably ignorant overview of some of the historiography. But we know that the link between environmentalism, economic status, health, and social ethnic background is now a large area of research. Francois Jarige, have I said that correctly, and Thomas Leroux, I'm looking around guiltily there, have recently underlined that there's always the poorest people globally that suffer the most from pollution. And it's surely not a coincidence, is it, that one of the largest chemical disasters took place in one of the poorest regions of India in 1984, and that gas leak at the Union Carbide pesticide plant at Bhopal killed tens of thousands of people. Where are they living? Shanty towns and around the chemical plant. Matthew Hubber has recently stated, quote, "If we are concerned about climate change and ecological breakdown, it remains an issue of industrial production." So underline that industrial production bit, because that seems to have got lost a little bit, I think. I think he's right. He persuasively argues the entire human relationship to the natural world is at its core a relationship of production, how we produce the food, energy, housing, and other basics of life. End of quote. This is why I find it quite interesting, you talking about your carbon footprint. By contrast, guilt over everyday consumers' carbon footprint was actually first populated, I didn't know this, but was first popularised between 2004 and 6 by the British oil giant, British Petroleum. And of course, canonised in ExxonMobil's advertisements, all shifting the blame for climate change on you, the consumer. You don't have to buy this stuff. What's wrong with you? Consumers, of course, do not own and control the firms. Having made and encouraged mass consumption of items such as products, these corporations now blame demand for climate issues, not on their production, but on you. So the relationship between capitalism, the environment, transport and labour relations, and I think a really good example is told by Thomas Andrews' history of coal extraction in Colorado's mines, culminating in the bloody 1914 Ludlow massacre. If you haven't read the book, it's quite an eye-opener. The early pioneer responsible, this is why I like it, but not like it, but I mean, for opening up the Rocky Mountains west, William Jackson Palmer got his inspiration from a tour, guess where? Northwest of England. So that was his inspiration. Led to, of course, a massive acceleration of using fossil fuels in general as well to drive the economy. And other people you've heard of shedding doubt, as Naomi Orskes and Eric Conway have shown, is an extremely powerful tactic to demonstrate, tobacco doesn't cause cancer. Look, these two scientists have shown that. You shed doubt in what people think. We're not having a climate issue at the moment. That's a very powerful instrument, and that's such a powerful one used by popularisers in politics and over immigration. All sorts of issues can be twisted and put doubt in your mind, leading to a Dutch election with anyway, we don't want to go there, we've been there already. Any solution to climate change has to, I think, you have to start looking much more seriously at the producers. It's bizarre, isn't it, how we're so obsessed with regulating our own private property that we forget about natural property, as Thomas Paine long ago said, i.e. earth, air and water. And I think you can get that sense in the historiography if you look at the emphasis on the commons by Peter Linebar, the recent New Economics by Kate Rayworth, all emphasising doing more to preserve and protect those areas. And this other thing I was really interested in, I was just thinking when I was looking at this, the neoliberal obsession since the late 1970s has informed the historiography a lot. I don't know what it's like so much in France, but in Britain, every other book that comes out is on consumption and demand, and I think it's also infiltrated a lot of that area as well, at the expense of production. So that's why I'm interested in kind of seeing if I can get funding to look at this deeper, because the archives are untouched really. And the people who do history of chemistry tend to be ex-chemists, and they're not interested particularly in this area so much.